from homework. Up to this point, we've assigned worksheets 1 and 2, 11 through 14, and 17 through 18. What do you guys got for questions? Aaron?
This isn't like a specific question on the board.
Sure.
When like you're given like the pi over 2, or like theta is like greater than pi over 2, or like less than like negative pi over 2 or whatever.
Sure.
How do you know like if you're supposed to shade like above or below, or like to the left or right?
Okay. So if you have something like this, and let's just say, I'll just make something up to go along with it. Sound good? So to draw this part, I know my theta could be negative or positive, right? So if I start at 0, if it's negative, I'd be going this direction. If it's positive, I'd be going that direction. Either way, I'm going to be covering quadrants 1 and 4. And looking at this piece, I guess we should color code this to match, huh? If I'm looking at this piece, that sign is negative. So sign is negative in T and C. So my result should be there.
But it's just, so it's like the blue is just like all
Well, think about it this way,
I guess like what is it going to be on the left?
I mean, if you had pi over 2 to positive 3 pi over 2, right? So it just kind of depends on, like, the angles between 0 and pi over 2 are in quadrant 1. The angles between negative pi over 2 and 0 are in quadrant 4, right? So it just kind of depends on what the numbers are. Is that?
Yeah, that makes sense.
Okay, yeah, of course. Happy to do like a hypothetical. Loose.
Did you do 2 and
Worksheet 2, number 2, coming up. So the first thing that I'd want to do is I'd want to look at the problem and decide whether this is a calculator problem or a unit circle problem. To do that, basically I'm just looking at whatever's inside the inverse. Is that a unit circle coordinate, 0.56? No, right? So it's a calculator problem. So to start any calculator problem, I'm going to draw a picture. And to draw the first part of my picture, I'm going to be looking at my range of values. So, what's up?
Is there any more worksheet 3s?
No, I've never handed out a worksheet 3.
Or I forgot which number it is. The ones that are due Sunday.
I probably, but I'm not going to get up and look for one right now. But at the end of the class, if you remind me, I'd be happy to take a look. Okay. They're also in the OneNote, too. So if I look at 2 pi to 3 pi, that tells me my answer is got to be positive because it's between 2 positive numbers, right? So I know I'm going to be going counterclockwise. I'm going to be going that direction. And I'm just going to label my axes, where each axis is pi over 2. So the first one was pi over 2, and then 2 pi over 2 are just pi. and then 3 pi over 2, and then 4 pi over 2, or 2 pi. So that's the start, right? And then 5 pi over 2, and then 6 pi over 2, or 3 pi. That's the end. So I'm looking at quadrants 1 and 2. Does that feel okay there, Luz? Okay. Now I'm going to look at my equation. I know that theta equals cosine inverse of 0.56 is the same thing as cosine theta equal 0.56. Since that's positive, I'm going to use my all silly turtles crawl and see that cosine is positive in A, where everything is positive, and C, where cosine is positive. So I have that. So far, so good. I'm now going to draw my standard position angle. So there's my initial side. I'm going to go around 1 full time and then end somewhere in quadrant 1. So far, so good. Because when I was counting, I went around 1 full time before I was done labeling my axes, right? All right. So now I will draw in my alpha. My alpha is always drawn between the x-axis and the terminal side. So there's my alpha. And alpha is always going to be the inverse that I'm given, but with an absolute value around. Now that I've got this, I have everything I need to write my answer. So I'm going to write theta equals. And the first piece of my answer is going to be whatever the label on the x-axis is that makes up part of my alpha. So again, alpha is right here. So I want 2 pi. So far, so good. To decide if I want to add or subtract, I need to look at the last axis I cross on my way to the terminal side. So that's an x-axis. So we had a couple of rules. If theta is positive and the last axis we cross is x, that means add. If theta is positive and the last axis we cross is y, that means subtract. And if it's negative, those rules are flipped. So we are right here. So this should be plus, and the last thing is always alpha. So the reason I'm drawing my picture is to figure out that equation for theta. What, and then plus or minus alpha is going to give you my answer. So far, so good. At this point, I can fire up my calculator. Got to make sure that I'm in radian mode. So I'll change that. And then I'm just going to do 2 pi plus cosine inverse. And then I'll do the absolute value of 0.56 in my head, just 0.56. So my answer should be about 7.26. To check that answer, I'm going to do 2 things. I'm going to take this, plug it in for theta to make sure I get 0.56. So cosine, if I do second ants, that'll give me the, or second negative sign, that'll give me the last thing I entered into my calculator. So that does give me 0.56, that's good. And then I want to make sure that 7.26 is in between 2 pi and 3 pi. So the easiest way to do that, I'll just type in 2 pi into my calculator. So I'm bigger than that. And I'll type in 3 pi, and it's smaller than that. So I am 100% sure that I have the correct answer, as it fits both, satisfies both the equation and the interval that I'm given. Does that feel okay?
Yeah.
So on this one, one of the probably the most common mistake, if you're like, ooh, I thought I had it and I goofed up, is making sure that as you're counting around that second or third or whatever time, you're crossing out the old label and replacing it with the new label. Easy to get goofed up if you don't do that. Who's next? Other questions?
You're going around, you just always increase by half.
Each quadrant is always half a pi. Yes, always. Because each quadrant is 90 degrees. And pi over 2 is just 90 degrees in radian speak. You know, just like yes in Spanish is sí. You know, it's the same, means the same thing, it's just different language.
Can you do one that's not a calculator?
Yeah, you want to do a unit circle one? You want me to pick the worst unit circle one?
No, just
Or a representative unit circle
a
one?
normal one.
Just a normal one. Okay. Shh. Just FYI though, like this little guy here, that's something that you'll want to remember. Probably a good note card thing. Just as a heads up before I move on here. So let me just grab some like whatever. I'll grab that one, I guess is fine. How's that fan sounding on the projector? Yeah, I think it might. All right. So if I look at this one, what is my cue to know that this is going to be a unit circle problem as opposed to a calculator problem? That's a unit circle coordinate, right? So I know that on the unit circle, sine is y. So I'm going to go to my unit circle and look for where the y coordinate is negative 1/2. So let's grab that unit circle. I am going to just go insane one of these days from this stupid noise. All right. Yes. So I see y equals negative 1/2 here at 7 pi over 6. And then I see it is equal to negative 1/2 here at 11 pi over 6. So far, so good. Now I just need to check to see if either of these answers work. So, two ways you could kind of think about this. You could do it with your calculator. You could convert everything into decimals and just see if 7 pi over 6 is in between these two, and then 11 pi over 6 is in between those two. Or you could think about it as, okay, pi over 2 is here, 3 pi over 2 is here, and we're talking about positive things, so we're covering counterclockwise. So we're just looking in quadrants 2 and 3. Well, that's my answer in quadrants 2 and 3. Right? So either way of thinking about it is fine, but that's it. That's my answer. I'm done. If neither of them work, then we would want to add or subtract 2 pi to each of them and check again. But it's easy because this is on the unit circle anyway. If that's not on the unit circle, then you're probably going to have to add or subtract 2 pi. Well, pi over 2 is here, and 3 pi over 2 is there, and we're positive, so we're going this direction. So we covered quadrants 2 and 3. Does that feel okay? So I'm just literally just reading it off the unit circle, right? I just have to know where to look. Actually, I don't really need to erase those for any reason. What do you guys think? More questions? Want to do some more stuff from these homeworks? I know that they're tricky till you get the hang of it. The nice part is they're all like basically the same. Like you can kind of attack them all the same way if you just know what to do. You know, when I come up with a procedure, it's try to make it like covering all the cases so that you don't have to learn like 8 procedures. It's just like one that you do all the time. You just, maybe it's more complicated than like the simplest little shortcutty thing, but it works the same way every single time. So I have to like sit there and try to decide what to do. You know what to do. It's just the same thing every time. That's my hope. Anyone else with questions from homeworks? Mira, do you want to see what this looks like in kind of the worst case scenario, having to use the unit circle? I mean, it's up to you, man. You know, I know how to do it. We'll do it though, right? It's a good thing to do. I think that 11 was the worst one. If you ask my opinion. Or at least the trickiest one. Well, I'm surprised that took that with me. I don't want any of that stuff. Okay. All right. So the tangent ones are the worst ones. Because on the unit circle, what's tangent? It's y over x. So you might say, okay, well, I'll just go to the unit circle and look for where y is square root 3 and x is 3, right? Do you see those anywhere on there? No. So tangent is tricky because it's the division of 2 unit circle coordinates. So usually there's like some reducing or something that's happened along the way, or rationalizing a denominator that makes it harder to see what you're looking for. Now, I don't even see a 3 anywhere on here, right, on the unit circle. I see like square root 3 is over 2, but I don't even see a 3 anywhere. So what I'm going to do is I'm going to think about that 3 as the square root of 3 squared. Everybody's okay with that 3 is equal to the square root of 3 squared? Yes. Now, if I have the square root of 3 over the square root of 3 squared, how can I simplify that? I can cancel, right? Now, if I go look on my unit circle now, do I see a place where y is 1 and x is square root 3? No, but I do see a place where y is 1/2 and x is square root 3 over 2. So if I just kind of multiply the top and bottom by a half then, now I have what I'm looking for. So my x has to be square root of 3 over 2. My y has to be 1/2. Or, since they're being divided, they could also be both negative, right? Because negative divided by negative is still positive. So I notice I got one here. That's pi over 6. And then I have this one here. So that's 7 pi over 6. I'm going to just turn off this projector for a minute and then turn it back on and see if, like, just letting that fan stop for a minute will keep it from making this terrible noise, because I'm about ready to take a baseball bat to this thing. It's driving me just absolutely insane. And it's been a long day and I don't have that much sanity left. I'm crossing my fingers and hoping that that just kind of like at least makes it a little bit better, because boy, that was getting real old real quick. So cross your fingers. I don't see anybody with fingers crossed, and it's thank you. Nah, didn't seem like. Oh, maybe that's a little better. No, doesn't seem like it. All right. So I have my two answers, right? Now I should be able to see right away that neither one of them are going to be between 3 pi and 4 pi, right? I have 1/6 pi. That's less than 3. And 7/6 pi, which is like 1 1/6, still less than 3. So what am I going to do then? Since neither of them fit, and I know one of them has to, I'm going to add 2 pi to each one to find an angle that's coterminal to it. Now, how do I know I should be adding 2 pi instead of subtracting? Because these were too small, right? They were less than the small end. They were all both less than 3 pi. Is it always going to be 2 pi? Well, if you're doing coterminal, it's always 2 pi. Always 2 pi. So to add those fractions, I need to make a common denominator. So I'll think about that as 2 pi over 1. The common denominator between pi over 6 and 2 pi over 1 would be 6. So pi over 6 plus 12 pi over 6 is 13 pi over 6, which is 2 1/6, which is still too small, right? So I know that is out. So if I make a common denominator here, I'm just not going to show the work for it. Is that okay with everybody? Yeah. So that's going to give me 19 pi over 6. 19 pi over 6 is 3 1/6 pi, which is between 3 pi and 4 pi. That one will work. Jamie. Of course. You're welcome. Mira, does that feel okay? This is like the worst case scenario. That's about as hard as they get. And the worst part is really just like figuring out getting to there, right? The easy way to think about it, though, is that this is just the same thing as 1 over the square root of 3. That's what I remember. Anyone else with questions from these homeworks? Okay. Today, we're going to do section 4.2. This is a pretty straightforward section. There's just like I should say two pieces of vocab that we need to talk about. So we have angle of elevation. And angle of depression. And I'm not going to define either of these terms in words because that's not how we're going to use them. We're going to be using them visually. So I'm going to give you like a pictorial definition. So let's say we have two people. One people's up high, one people down low. Some good English, Mr. Kulik. And let's say this is like their line of sight where they're just looking straight ahead. Everybody feel okay there? If we're the person up high, we're looking straight ahead and we want to look at the person below us, we have to like tilt our neck down, right? So if I change my line of sight like this, that's an angle of depression. If you're the person on the ground, you're looking straight forward and you want to look at the person up high, you have to lift your line of sight up. So that's like our angle of elevation. Does that feel okay? What is the relationship between angle of depression and angle of elevation? Good. Why? Do you remember? So it's a geometry reason. So they are, the term is alternate interior angles. So if you have two parallel lines cut by transversal, the alternate interior angles are congruent. I think it's the theorem. That sound familiar? Usually we do a pretty thorough job on parallel line stuff in geometry. That's a big point of emphasis. What's the relationship between, say, this angle that I've starred and the angle of depression? What's the geometric relationship between the angle of depression and that starred angle? They add to give us 90. They're complementary. The theorem is those are consecutive interior angles, was the name of that theorem. Will I ask you to quote theorems to me ever? No. We're just kind of like connecting back to geometry. There's a lot of overlap. It's good to mention these things again, right? Some of us may be taking ACTs, and that's stuff that comes up all the time on those tests. Sure. Okay. The most common mistake students are going to make is you're going to put the angle of depression here. We need to watch out for that. All right. Let's do some examples. So the homework in this section, I'm going to give you a story problem. And then you'll be asked to build a picture and solve. So it says, Christy is looking up at the Fisher Building in downtown Detroit. She is standing 200 feet from the base of the building and finds the angle of elevation to the top of the spire to measure 66 degrees. How tall is the Fisher Building? So here's Christy, there's the Fisher Building. It says we're 200 feet from the base. Notice that I can assume that it's a right angle, right? Any structure that's on the ground you can assume is perpendicular to the ground unless explicitly stated otherwise. And then we want the angle of elevation is 66 degrees. So that's just going to be that angle. And we want the height of the building. So we want that side. Everybody cool with the setup? Okay, relative to that 66 degree angle, the 200-foot side is opposite, adjacent, or hypotenuse. Adjacent. The H side is opposite. So the trig function I need is tangent. So I'll say tangent 66 equals opposite over adjacent. To solve for H, all I need to do is multiply both sides by 200. And I'm donezos. Ooh, but before I type this into my calculator, what do I need to do?
Change the mode.
Yes, change the mode to make sure it's in degree mode. Mr. Kulik, is this going to happen on the test? You betcha. So make sure you're being real careful about looking at the problem and deciding whether your calculator needs to be in degree and radian mode. Should be easy to tell. If the angles have pi's in them, should be in radian mode. If the angles have degree symbols after them, should be in degree mode. So my answer then should be 4449.2. You guys feel okay on that? Pretty easy, right? We like these. Seems like you guys are pretty comfortable with these SOHCAHTOA-ish problems. We saw those things on the first test, and that typically went pretty well for us. All right. So here it says, Jane has climbed a tree and is looking down on her friend Mary. Jane has climbed 17 feet into the air, and the angle of depression to Mary is 49 degrees. How far is Mary standing from the base of the tree? Okay. Well, so let's see. There's Jane and Mary. 17 feet up in the tree. Where's that 49 degree go? You put it here, right? No. Good. Where does it go? Yeah, so Jane's line of sight would be here. So the angle of depression should be there, right? What could you put here? the complement to 49. So like 41 degrees. Or what could you put here where M is? "49 degrees could go there also, right? So it doesn't matter how you label that, but it can't have 49 here. I will promise you with 100% certainty that I will try to trick you again with this exact same problem setup later on a test, to make sure you're putting that angle of depression in the correct spot when you draw your picture. Is everybody okay? Don't be fooled by me a second time if you're fooled on this one. Okay? All right. So let's say that we put the 49 here, and we instead thought about this triangle. Everybody's okay with that? Still the same triangle as the red one, and just oriented in a different direction. Relative to the 49 degrees, the 17 is? Opposite. And the x is? So I need tangent, which is opposite over adjacent. Everybody's okay? To solve for x, I'm going to start by just getting it out of the denominator. So I'll multiply both sides by x. And then divide both sides by tan 49. And my calculator is already in degree mode. I saw to that earlier, so I don't have to worry about changing it again. So I get about 14.8 feet. Oh. Feel okay? No big deal there. Other than that, again, making sure you get that angle of depression in the right spot. Promise you I'll try to trick you. Do that same trick again. Don't be fooled. All right, one more example and we'll be done with 4.2. Claude and Simone are riding bicycles in Paris. How romantic. At one point, they look up and measure the angle of elevation to the top of the Eiffel Tower to be 32 degrees. When they pedal 100 meters closer to the tower, the angle of elevation changes to 37.5 degrees. How tall do they estimate the Eiffel Tower to be? Okay, well, let's draw our picture. There's my Eiffel Tower. So my original angle of elevation here is 32 degrees. Then I go a little bit closer. And now my angle of elevation is 37.5 degrees. I guess I went 100 meters closer. And we're interested in how tall the thing is. Everybody good with my picture that I drew? Okay. So if I take a look at this picture, when I look at this, what I see is I see two right triangles. I see the big green triangle, and then like the smaller blue triangle. So far, so good. Do I care about any non-right triangles? No, because can I do SOHCAHTOA on those? No. That's why I only care about the right triangles. Now, in either the green triangle or the blue triangle, do I know both a side length and an angle measure? No, right? So that's going to be a little bit of a bummer. Let's redraw these two triangles and kind of think about what we have. So I'm going to draw the two separately here. So here's the green triangle. What should I call the base of that green triangle? Well, no, I need a label on it. Not opposite, adjacent, hypotenuse. Well, here's what I notice. Because I do know a little bit about it, right? I know like this much of it is 100 degrees or 100 meters. Everybody agree with that? And I notice that this part of it is part of both the blue triangle and the green triangle. You guys see that? So I'm going to give this part a name. I'm going to call it X. If I do that, what should I label the base of this 32-degree triangle as? Close. 100 plus X. Right? Because if you go 100 meters and then you go X meters more, you're at the tower. Everybody agree? And now if I draw the blue triangle, I'd label it as base of X and height of H. Everybody good? Notice in each triangle I have two variables, right? If I have an equation with two variables, I need to form a system of two equations in order to solve that. So from the first triangle, I'm going to say that tan 32 degrees is equal to opposite over hypotenuse. And the second triangle, I'm going to say tan 37.5 degrees is equal to opposite over adjacent. And that's going to form my system of two equations. If I'd like to solve this algebraically, my two techniques for algebraic solving of a system are substitution and elimination. My choice here would be to use substitution. So what I want to do is I want to get one of these variables in one of the equations by itself so I can substitute it into the other. Now, do I care about the value for both X and H? No. What is the question really asking us for? Only H. So what I'm going to do is I'm going to isolate the X only so I can plug it in to the other equation and get rid of the X's. So I'm left with just H's to solve for. Okay with that plan? Does it look like it's easier to get the X by itself in equation 1 or equation 2? 2. So to get the X by itself, I'll multiply both sides by X. And then divide by tan 37.5. And I'm going to take that value and substitute it in for the X in the other equation. Does this all seem okay so far? Okay, let me know if I get going too fast. Sometimes I just get excited about the math and start really cranking, especially after I've done it twice already today. This is time number 3. So if I look at this equation, I say to myself, oh, yuck, right? This looks nasty. So there's several things I don't like about it. First thing I don't like is that I have a fraction inside of a fraction. Right? You guys see that? Right, I have this little fraction inside of the bigger fraction. Yuck. So my first order of business is going to be to get rid of that little fraction inside of the big fraction. To do that, I'm going to multiply both the top and bottom by the denominator of that little fraction. So when I multiply h times tan 37, I just get h times tan 37. When I multiply 100 by tan 37, I just get 100 times tan 37. But what do I get when I multiply tan 37 by h over tan 37? What do I get? Tan 37 times h over tan 37. I just get h, right? I'm talking about this multiplication right there. Everybody see that? Okay, so that's a little bit better. I don't have that fraction inside of a fraction now, but I still have a fraction in general, right? And that fraction has a variable in the denominator. So my next order of business is just going to be to get no fractions in here at all. So I'm going to multiply both sides by that denominator, 100 times tan 37 plus h. I'll multiply that to both sides. Yes. Yes. So far, so good? All right. So no more fractions. That's an improvement. But there's still something I don't love about this. The part that I don't like is that the variable I'm solving for is in two different locations. So I need to then get that variable I'm solving for onto one side. So I'm going to take everything with an h in it and get it on one side, and the stuff without h's I'm going to leave on the other. Everybody's okay with that plan? Before I can move that first h, though, I have to distribute this tan 32 through. Oops. So I'll start by doing that. And now I'll subtract the h tan 32 so that both of my h's are on the same side. So far, so good. Now here's my question. I have h's, two separate locations. What can I do to get those h's into one single spot? Right? if I have 3x plus 5x on one side of my equation, how do I get the 3x and the 5x into one spot? Just add them together, right? I'd have 8x. So here, if I have x times tan 37.5 minus x times tan 32, to combine them together, I have to subtract tan 37 and tan 32. Would you agree with that? Now, real important, that is not tan of 5.5. But I can do that. What else does that look like? Going from this step to that step, what else does that look like? Kind of looks like you factored out a greatest common factor of h, right? Does that look kind of the same? It's doing the exact same thing, in fact. The distributive property is just combining like terms, just the other direction. All right. So to get the h now by itself, sure, I'm going to divide by tan 37.5 minus tan 32. And I'm finally at the end of this godforsaken problem. Now it's calculator time. To get this into my calculator, I definitely want to use that horizontal fraction bar, because this is going to be like a nightmare of parentheses to try to do without it. But with that horizontal fraction bar, I can just type it in exactly as it looks on my sheet of paper. And boy, that's a lot nicer. So I do that and I get 336.6. Guess those are meters. Whoa, that was a workout. Question for you guys, though. When you solved systems of equations last year in your Algebra 2 class, you talked about algebraic methods like substitution and elimination, but you should have also talked about a third method. Does anybody remember that one? Starts with a G and ends in a G. Graphing. Could also solve this by graphing. Let's go back to the original system and see what it looks like if I had taken that route. So to solve this by graphing, what I want to do is get the same variable by itself in both equations. If I look at my two equations, will it be easier to get the x by itself or the h by itself? Dude, I'm definitely picking the h, right? To get the h by itself in the first equation, I'll just multiply by 100 plus x. In the second equation, I'll just multiply both sides by x. So here, my points, xy's are going to be x comma h's. Since I've written h by itself, it's like the dependent variable there. Everybody's okay with that idea? Okay. So now I'm going to go to my calculator. And I'm going to go to the y equals menu. And I'm going to type in these two equations into y1 and y2. Everybody's okay with that? Just type them in just the way they looked. And then I'll just hit graph. So when I do that, I'm just getting, something's wrong, Mr. Kulik. I only see one line. Shouldn't I see two lines here? Did I do something wrong? What's the issue? Well, no, I didn't type anything in wrong. The issue is most likely the window on my calculator. I just graphed this on the standard window from -10 to +10. But x is some distance of meters to the base of the Eiffel Tower, and y is like the height in meters of the Eiffel Tower. Well, I'm pretty sure the Eiffel Tower is taller than 10 meters, right? So I need to change my window a little bit. Remember, x is representing that leftover distance here. So I know it has to be positive. I don't really know how much further, but if this is 100, what do you think's a decent guess for this one? I would do bigger than that. I'd say, I don't know, like maybe 500. I don't really know. I'm just going to go bigger than maybe what I think I need. Right? Because moving it, like if you're standing here, the angle of elevation is basically 90 degrees, right? Moving 100 meters only moved us like 5.5 degrees. Not that it'll have a linear relationship necessarily, but now for the y's, again, I don't know how tall the Eiffel Tower is, but it's pretty dang tall. 500 meters is like 1,500 feet. 500 meters is like 5 football fields. It seems like the Eiffel Tower shouldn't be taller than 5 football fields. That's pretty stinking tall. So that seems like a decent upper bound. Let's see what happens if I do that and then hit graph. So here's one line. That's good. I see one. Here comes the second line. That's great. What am I looking for to solve this system? The intersection of these two lines, right? So I can see that happening right here. That's fantastic. So if I hit second and trace and choose the intersect command. Now the calculator asks for 3 inputs here. It wants to know which 2 lines to look at and then about where the intersection is. But here's the good news. How many lines did we graph? Just 2. There's only 2 things on here. They're both straight lines. How many intersections can 2 straight lines have? Just 1, right? So it doesn't matter. I just can press enter 3 times and let it go. So it says my intersection is at 438.6, 336.6. So remember, my points are x comma h's. So this x is 438.6, and this h is 336.6. So we're done, right? Yes, sir. Sure. So, on a test or a quiz or your homework, which method can you use? We just looked at 2 methods to do this. Which method can you use? Either. Either is okay. If you didn't like the algebra, you can do it by graphing. The expectation would be that you give me your picture, You give me your system. You show me what went into the calculator. You show me a picture of what the calculator screen looked like when you graphed it. And then you can just write down your answer. Or you could do all this by hand. It's up to you. Whichever one you want to do. Will all the problems be like a nasty solving a system? Well, of course not. We saw 2 examples where it was like really pretty straightforward, right? Would you expect maybe 1 or 2 problems at most to be kind of like nasty like this one in the homework? I would say at most 1 or 2. Maris, that's 1 or 2 too many for Mira. You can do it. Just use your calculator to do it. It's not that bad. That's why I showed you the bad way first. So that hopefully when I showed you the good way, you'd realize how good the good way was. You know what I mean? If you have an ACT at any point, solving a system via graphing is a great option. It's a lot faster. Usually makes it really hard to make a mistake. It's a nice method to use. All right. Well, that's all I have for you guys. So your homework is going to be Chapter 4, Worksheet 3. I don't have that printed for you guys, but it is in the content library in OneNote. That'll be part of Sunday's homework check. We only have 15 minutes left or so. I don't think that's probably enough time to give the homework quiz. So when does that mean the homework quiz is going to be?
Friday.
It's got to be Friday, right? What else is happening on Friday? It's the test review day. So what else is due on Friday? Your note card. If you want to start making that in advance, you're welcome to do that. Did you have a bunch of formulas and stuff to memorize to put on this note card for this test? Not really, right? Probably example problems would be a good place to go. What's due for Sunday's problem set?
The worksheets, the 1 worksheet.
Worksheets 1 and 2, 11 through 14, 17 to 18, and worksheet 3, because we'll have a chance to answer questions about it on Friday. Sure. Everybody cool? What day is the test going to be if the test review is Friday? Tuesday. Everybody happy? No, Mr. Kulik, I'm in math class. I'm not happy. Well, everybody understand where we're at? Okay. All right, I'm signing off.